Graphical transformations are what we're going to talk about today. We're going to talk about three different kinds: vertical and horizontal shifts. Those will be my additive. Reflections. This will be a reflection where the shape will be the same on the X and the Y axis. We're going to reflect it across the axis. And then non-rigid transformations, which are going to be our stretching and our shrinking. First step is a quadratic. Now what I've graphed is actually just x squared. What I have listed here is x plus a, and at this particular point in time my a is set to 0. You can see that I have them set at 0, and b is also set to 0. They're both adding to the function, and right now they're actually adding 0, so they're not adding anything to the function. I'm going to call A my inside additive quantity and B my outside additive quantity. Let's look first at what B does. B, as you can see, is set to 0. As I increase B, meaning he's positive, you can see the function go up. We call this a vertical shift up. As B becomes negative, you see that it is a vertical shift down. So as B is positive, it goes up. The shape of the function itself does not change. When you add something on the outside, which is what B does, it is called a vertical shift. Let's look at A and see what he does. Now as I move A in the positive, so if I add a positive quantity, the shape moves to the left. As A becomes negative, it shifts this graph to the right. So adding on the inside shifts it left if it's positive and right if it's negative. Let's look at another function. Here I've graphed x cubed for you. Right now my a and b are set to 0, so it is just an x cubed. As b, which is on the outside, I'm adding on the outside. As b becomes positive, it goes up. As b is negative, it goes down. So I'll set b back at 0. And let's see, right there. And A is my inside additive quantity. If A is positive, it moves to the left. If A is negative, it moves to the right. And what happens if I have, say, an A of, say, about 2, and a B that's about 3? You can see that it takes the exact same shape and shifts it both to the left 2 and up 3. Here I graph for you the absolute value function with both a and b set to 0. We're going to see what the b does. B is once again being added on the outside. So b, if he's positive and it's like the other, should move it up. If b is negative, it should move it down, just like all the others. It doesn't really matter what function you graph. If you add a number on the outside and it's positive, it moves up. If you add a number on the outside and it's negative, it moves down. I'm going to add a number on the inside. If it's like the others, positive should move it left, and it does. And negative should move it to the right, and it does. Same thing once again. Here's a square root function. I have an a and a b on that one. The a is on the inside, b is on the outside. So if I shift b, if I make it a positive number, if it's like the others and it's being added on the outside, it should move it up, and it does. If a is like the others and he's being added, he's on the inside, a positive number should make it move to the left, and it does. And the negative number should make it move to the right, and it does. This is a sine wave, and we really shouldn't know anything about a sine wave. But if this is the graph of just sine x, then our b, if we make it positive, he's being added on the outside, should move it up. See how it's just like a little thin wire, and it just moves it up. The shape of it doesn't change. It's just a wire. It moves it up. If it's negative, it moves it down. Nothing really changes. Doesn't matter what function you graph. If you add on the outside, it'll either move it up or down, and that's called a vertical shift. A, as you can see, if it's positive, it'll actually move it to the left. You can see it flowing to the left. And if A is negative, it will flow it to the right. Same thing. In summary, what we have so far is that if you add on the outside, that would be right here. You add on the outside, you have a vertical shift, meaning that it moves it up and down. If C is greater than 0 or he's positive, you'll move it up. If C is less than 0, then that means it's negative and you'll move it down. Here you'll notice that C is on the, or your constant, is on the inside. And if C is on the inside, it will move it left and right, which is called a horizontal shift. If he's positive or greater than 0, it will move it to the left. If he's negative, it will move it to the right. And that's our summary of vertical and horizontal shifts. We looked at what additive quantities would do. Now what we're going to do is look at multipliers. First off, we're going to look at some reflections, and we'll talk about the reflections, and we'll also, as we do this, talk about vertical and horizontal stretches and shrinking. So first off, we're going to look at the outside multiplier. I have both A and B set on 1, if you'll notice. So A and B are both set on 1, so basically all I'm doing is graphing x squared. Let's look at the reflection first. Let's change from a positive B to a negative B. This is on the outside. So as I change B to a negative, he reflects across the x-axis. See, I'm reflecting across the x-axis. As B increases, I get what's called a vertical stretch. As B decreases and becomes less than 1, I get what's called a vertical shrink. So he's on the outside, I get a vertical stretch and shrink on the outside. Also, he's on the outside, and when he's negative, he reflects across the x-axis. So let me set B back on 1. Now let's look at A. A is on the inside. Let's watch what happens as he changes from positive to negative. We don't really see much. What's happening is he's reflecting across the y-axis. And if he reflects across the y-axis, I don't see anything on this one because he is symmetric to the y-axis. On my inside function, I also get what's called a horizontal shrink and stretch. I don't really see much difference in the vertical and the horizontal stretch and shrink because of the shape of this little guy. So I'll have to get something else, which I will have other functions where we'll actually be able to see that. Alright, now we've got our A and B both set to 1. I'm graphing a cubic. As B goes from positive to negative, it should once again reflect across the x-axis. Let's watch him. Boom, boom. See him flip across the x-axis. As B is positive, I get my vertical stretch. As A becomes less than 1, I get a vertical shrink. And you see him shrinking. Oh, and there he is at 0. He wipes out the function at 0. And then there's my reflection across the x-axis. Let's look at A. Should be a reflection across the y-axis when he becomes negative. And there he is reflecting across the y-axis. I also get my horizontal stretch and shrink, which is harder to see on this one. I have a good function for looking at the horizontal stretch and shrink in just a minute. Here's my absolute value function. I'm going to look at the B and how he reflects across the x-axis. See him reflect across the x-axis. That's nice. There he is in a vertical stretch as B becomes very large. And as B becomes a fraction less than 1, I have a vertical shrink. So put him back and look at A and see what he does. He's going to reflect across the y-axis. Now, what do you think? As it reflects across the y-axis, are you going to see any difference? No, you're not going to see any difference. But there is my horizontal stretch and shrink, which again, because of the symmetry of this function, I don't see the horizontal quite yet, but I will. Here's my square root function again. I'm going to watch as b reflects him across. But as b is negative, I'm going to reflect him across the x. See, b is negative, reflecting him across the x-axis. Notice as b becomes large, I have my vertical stretch. As b becomes a fraction less than 1, I have a vertical shrink. So put him back on 1. Let's look at my a. Now this is going to reflect across the y-axis. I'm actually going to get to see this one. So as a is negative, he reflects across the y. See him reflecting across the y as I go from positive to negative. Now as a becomes large, I get this horizontal stretch and my horizontal shrink, which I can't really see on this function once again, but I will on the next one. Okay, this is my favorite function for showing vertical stretches and shrinks. Let's watch him reflect across the x-axis as b, which is my outside function, becomes negative. See him reflect. Now as b becomes large, there's my vertical stretch. Isn't that way cool? Then as b is not negative, less than 1, he's a fraction, he gets really tiny. See, he's just really tiny there, so I'll put b back on 1. Now here's the goodie where you get to see the inside multiplier. You get to see that the inside multiplier stretches and shrinks this thing. Okay, are you ready? I'm going to make a be large. Up. You see this horizontal stretch and shrink. As a is large, I get this horizontal shrink, and as a is less than 1, I get this horizontal stretch. Horizontal is always backwards what you think it is, but let's see, when a is negative, it is a reflection across that y-axis. You see it reflect across the y. We'll go from positive to negative, and you can kind of see that happening there. All right, so we'll go back and summarize. Reflections on the x-axis. If I have a negative on the outside, it reflects it across the x. This is a negative on the outside. Here is a reflection on the y-axis, and this happens when you have a negative on the inside. And here we have our non-rigid transformations, which just means that it changes the shape of the function. We have a vertical stretch or shrink if my constant is on the outside of f of x, and we have a horizontal stretch or shrink if my constant is on the inside of my function. And that's our summary for graphical transformations.